Today we're going to be discussing mobile systems. An introduction to mobile systems are composed of include base stations, we refer to them as BS, switching systems, we're going to be talking about the mobile switching center, and various data processing functions in terms of internet working operations. We're going to come across that in a little bit. The radio system portion of the mobile network, which is referred to as a radio access network, some people refer to it as RAN. Mobile networks interconnect wireless devices in terms of cellular phones, mobile workstations, and so on, embedded radio modules, and so on, with nearby radio towers that route calls through switching systems to other wireless telephones, to other telephones or data networks. Creating and managing a wireless network involves equipment selection, installation, implementation methods, interconnection to the public switching telephone network, PSTN, and other networks such as the Internet. The mobile systems used either in a mobile switching center is MSC, which is referred to as mobile switching center for voice and medium speed data or packet data service, such as PDSN for packet data services for the connection of the Internet. The mobile switching center coordinates the overall allocation of routing of calls via algorithms. So we will talk about the concept of algorithms throughout the wireless system, whereas the PDSN, packet data service node, ensures package from the mobile devices can reach their destination in terms of the internet connectivity. It's going to be looking at the MSC versus the PSTN. Mobile network functioning diagrams. We're going to look at this entire diagram here in terms of the equipment selection in terms of mobile equipment, referred to as ME, which is doubly connected to what you call a subscriber information module or data chip. The access of the base station controllers or cellular sites and the radio access network, right? So these are the base stations, and these sites and them are connected to the core network, right, for voice and data transmissions via the PDSN. And the data transitions, we're going to be talking about the serving gateway supporting nodes, and we'll also talk about the differences between the SMS gateways as well that connect to the public switching telephone networks, right? The serving mobile switching center and the gateway mobile switching centers. We're going to talk about these two concepts in a little bit. We're going to talk about the whole idea of the HLR, otherwise known as the home location register, which is also connected to the visitor location register, which is a subset of the HLR. These visitor location centers, we're going to be talking about registers that is going to be set up all over different parts of the country, let's say for Trinidad and Tobago. But each network have one HLR. And we're talking about the equipment identity register in terms of EIR. Continuing with the equipment identity register, we're going to talk about the whole concept why it is that when you lost a cellular phone or somebody lost a cell phone, why it is so important for you all to call back the person and not to keep that cellular phone that doesn't belong to you in terms of the phone being registered. So we're going to look at the different types of hats, black hat, white hat, and grey hats in terms of cellular technology. We're going to move on by the mobile network diagram. Again, the user equipment, radio access network, and the core internet networking functions, which we discussed earlier, which is basically composed of three key parts. As you can see, the diagram here is again, I have the diagram repeating in itself so for you all to have a conceptual view of how the three different sections of the mobile systems work in terms of the user equipment, which is the mobile workstations or your cellular phones or your LAN mobile phones and so on. Right, your radio access network, otherwise called as the RAN network, will connect to what you call base stations, right? And your core network, which is your voice network, as well as the data network, which connect to both to the public switching telephone network and the Internet. The user equipment is divided into two parts, and we discussed that already with the mobile equipment and the subscriber identity module. We talk about SIM in terms of GSM architecture, that this SIM card we discussed it in our earlier lesson. Right, the mobile equipment, we said already, we've made reference to mobile equipment in terms of LAN mobile phones and mobile workstations, or what we refer to as cellular phones. The radio access network composed of base stations and base station controllers. So you have BS and BSC controllers. And all these examples show that the base station controllers connects voice call to mobile switching centers, MSC, and connects data sessions to packet data service of the PDSN. So we could see here in the diagram that the radio access network connects to either to the mobile switching center for voice calls for PSTN, or the radio access network is connected to the PDSN via the Internet in terms of data services and so on. Alright, so the network core is basically circuit switch, which is primary voice, and packet switch is primary data. So circuit switch basically operates within or contains what I should say the serving mobile switching center and the gateway mobile switching center. We'll talk about the differences between the two of them in this slide, and then we will talk about it when we come back when we're looking at the MSC, a whole topic by itself. So the serving mobile switching center connects to the RAN network, and the gateway connects to the public switching telephone network, which is the MSC, and of course it will connect to the public switching telephone network because you would need a gateway to connect to LAN mobile phones as well. Well, LAN phones I should say in terms of analog technologies, so you would need a gateway to connect, whereas these mobile switching centers will connect from cellular technology, which is wireless, from cellular technology as well, like Digicel connecting to Digicel. We'll talk about the whole concept of the gateway mobile switching center that connects GGSN to B Mobile as a typical example. Alright, so the packet switching is primary data. We'll talk about serving general packet radio services, the GPRS supporting node, SGSN, and the gateway GPRS service node, which would connect to the internet. As we can see here in this network here, we're going to see that it's serving GPRS nodes, right, in terms of radio services, in terms of packet data, and of course we will need the gateway services to connect to internet technology, which internet is wide, vast in terms of just not only mobile alone, but we have computer systems as well, radio, and anything else. Even a fridge might be able to connect, you understand, in terms of the internet connectivity and so on, because the technology is getting so robust today and so developed. So with base stations, we typically going to talk about in terms of antenna systems, in terms of connected to buildings, and base station radio equipments, in terms of RF equipment, transceivers and antenna interface equipments. We have controllers too on the power supplies. So all these base stations may be standalone transmission systems or parts of a cellular site, and is composed of the following that was just identified. And the question is, why do base station transceivers are said to have many of the same basic parts of a mobile device? Because it's very simple. They have what you call radio transceivers and receivers, right? Transmitters and receivers assemblies, I should say. Right, so transmission section converts voice or data signals to RF for transmission to the wireless signals. So you have RF signals being transmitted when it's being transmitted outside. And then when the receiving section will convert that RF signals from the wireless device to voice or data signals routed from the mobile switching center or packet switching services. So when you're having the receiving coming to your phone, is that RF signal that is there, that is wireless, that needs to be converted back to voice, right? Sent to the mobile switching center, either for packet data services or for voice calls. So when we're reviewing the base station controllers, we're looking at cell sites to provide coverage. They can be identified by towers that are used in Compton Hill, for example. And we'll typically have high wattage power between 10 to 100 watts of output power, which high output power and high towers. The base stations can have a range of 30 kilometers in rural areas, and we talk about 500 meters in urban areas and so on. So we're going to talk about in terms of the closeness, in terms of how you will set up your cell sites and so on to minimize what you call interferences and so on. So this is a typical example here in terms of the mobile power, which is 0.5 watts on a mobile workstation or cellular phone, versus a base station that will transmit between 10 to 100 watts according, you understand, to the amount of base stations are set up within a specific area. For example, rural is 30 kilometers and urban is 500 meters in terms of that. So we'd have the reverse and the uplink here shown here in terms of the mobile workstation connecting to the cell site. There's a reverse uplink here, and then your downward link, that is the downward link that will be send the transmission back to your mobile cellular phone. So the range of base station is designed using the number of subscribers in the areas. So we're going to talk about that in terms of the urban areas, which high subscriber densities. The base stations may have a range as small as 500 meters because it's urban. There's a lot like Port of Spain, for example, right? And we talk about the concept of forward and download in terms of output power, 0.5 watts in minimum or maximum, I should say. When it comes to a mobile phone, it would not generate more than that. Hence the reason for your cellular technology to minimize its battery power. And the reversal uplink, we talk about signals on the mobile phone that transmit back up to your base station. Right? So radio antenna towers, wireless base station antenna heights can vary from few feet to hundreds of feet. For example, Compton Hill. And then sub-radio towers too as well have antennas that will connect to have that specific radio coverage over Trinidad and Tobago, like Boom Champions, for example, 91.9 FM. They will have their own personal radio antennas to send across a certain area. Alright, and these antenna systems, for example, we talk about the LMR radios, we'll talk about that in a little bit. There may be several different antenna systems mounted on similar or some or the same radio towers. For example, in Comerton Hill, some of them may be used for paging system, point-to-point microwave communication link, or land mobile phones, LMR. And these mobile phones are normally used typically for police and ambulance and so on, so they normally don't pay. They actually have that free area of the electric magnetic spectrum to use in terms of LMRs, and LMRs also is used for airplanes and so on. Alright, communication systems. Alright, so these are examples of the LMR phones. Some people like to refer to them as walkie-talkie telephone systems that are designed basically in either vehicles for engineering purposes, or for example on radio that is connected to airplanes and so on. Alright, and of course we will talk about the concept of sharing. We talk about the whole concept of frequency use. We're talking about the whole concept of sharing the towers, for example in Comerton, by different types of radio systems, in which are very common due to the economies realized by sharing the cost of the tower. So for example, you find that radio station may end up sharing it in terms of it to benefit from large scale production, economies of scale, and so on. The benefits derive from large scale production. So sharing is important to avoid. But however, when you're doing that, great care must take into consideration, especially for testing, to avoid what you call mutual radio interference between various systems and so on. Like for example, on one of those model aircrafts and so on, you would find that different people, even though that they would share communication and share towers and so on, they would have different bandwidths and spectrums and so on to use now as well. So, for example, communication links. Right, we could talk about the concept of most of you all will refer to these things in ITEC 250, copper wire, in terms of UTP and STP, microwave radio links, and some of the IEEE standards for Bluetooth, and then it has also for wireless technology for mobile phones. So you'll have to learn the different types of IEEE standards and so on, and then for fiber optic links and so on. So these are the type of communication links that could be used. There's just this tree alone that I have named. Right, including Bluetooth that make it 4. Duplicate and alternative communication links can sometimes be used to help ensure communication and may continue in the event of failure or communication lines, such as when a cable sequence with backhaul cuts a line and so on. So you could find that you could have a combination of both fiber optics, microwave links and so on, set up and design when it comes to mobile systems and so on. And sometimes you will find that, like flow might go down for a while because they're doing some maintenance on electrical wiring or something like that. Right, same thing here for mobile phones. Right, so these are examples of some of the communication links which most of you all already are familiar with. Fiber optics in terms of the electrical conduits and so on. This is shielded twisted pair here as well. We know about this. Microwave links, fiber optics technology here. All right.